Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to your YouTube channel Chandan Physics. In this video, we are going to discuss geometrical structure factor. Let's begin. We know the structure of a crystal is the combination of lattice plus basis. Lattice is an infinite array of points in space having equal surroundings. Basis, the arrangement of group of atoms. When we combine these two, one is lattice and another one is basis, we obtain the crystal structure. Unit cell is the fundamental building block of that crystal structure. Means if we organize a huge number of unit cell, then we obtain the shape of the crystal. Let me consider an unit cell. Simple cubic unit cell. The atoms are the corners. When X-rays are incident on that of crystal, means X-rays are incident on that of unit cell as well as the atoms present at the corners of that of unit cell. After incident, these are scattered. Finally, these scattered radiations or scattered waves interfere with each other, and different crystals have different kinds of scattering pattern, because the path difference covered by X-rays after reflection from different atoms, the total intensity of scattered beam from a unit cell is not equal to the number of atoms the times the intensity of the beam scattered by the atom. Therefore, the intensity of beam scattered from that of crystal depends upon various factors. The intensity of a beam scattered, a scattering beam from a crystal depends upon the atomic scattering factor. The atomic scattering factor, as we have already discussed in the previous video about atomic scattering factor, and also the number of atoms in the unit cell. There are various kinds of unit cell as simple cubic, body centered cubic or face centered cubic. On that basis, what will be the number of atoms present in that of unit cell? And the types of atoms. Types of atoms in the unit cell. Types of atoms, if the atom is sodium, chlorine or any kind of atoms, that also influence what will be the intensity of beam scattered from that of given crystal. And again, the distribution of atoms in the unit cell. What number of atoms and how these atoms are distributed along that of unit cell, that play an important role for the intensity of a beam scattered from a crystal. Therefore, to analyze the shape of that particular crystal structure, we introduce a term, that is geometrical structure factor. Geometrical structure factor is defined as the ratio of the amplitude of the wave scattered by an entire unit cell to the amplitude of the wave scattered by a single point electron for the same wavelength that present at the origin. Mathematically, we say geometric structure factor that is defined as the ratio of the total scattering amplitude. Total scattering amplitude, we denote it as capital F H K L. Total scattering amplitude, here as H K L we call it as Miller indices, and it will be same for the parallel set of planes. So, F H K L, the total scattering amplitude. 2. The atomic scattering factor. Atomic scattering factor denoted by small f, that is geometrical structure factor zeta is equal to total scattering amplitude F H K L to that of atomic scattering factor small f. Therefore, geometrical structure factor zeta is equal to total scattering amplitude F S K L divided by atomic scattering factor small f. Now, we have to derive that equation of geometrical structure factor. To derive that expression, we have to consider, suppose there are n number of atoms in the unit cell of the crystal. N number of unit cells in that of crystal, and the position of any arbitrary atom, there are n number of atoms, but we choose any atom. Let that atom is jth atom of the unit cell. In unit cell there are n number of atoms, but we choose jth number atom, and that position of the jth atom is written as r j vector as xj a vector plus yj b vector zj c vector. So that position is so arranged, therefore xj, yj and zj, that are the coordinates of x, y and z of that of jth atom, that lie here. Xj, yj and zj are lie between 0 to 1. As we taken it, it is an unit cell, so the coordinates lie within 0 to 1. If f of j, that is the atomic scattering factor of that jth atom, therefore the total scattering amplitude of the crystal, the total scattering amplitude of the crystal for a given SKL reflection is total scattering amplitude f SKL is equal to summation over j from 1 to infinity f of j atomic scattering factor e to the power I phi of j. Phi of j at the phase difference. Phase difference between the scattered wave at origin and that of scattering from an atom. The phase difference in between these two waves, and that phase difference is given as 2 pi by lambda r j vector dot n vector. Rj vector, the position of jth atom that present in that of unit cell. Rj dot n vector, it can be expanded phi of j is equal to 2 pi by lambda Rj dot n vector, Rj as xj a vector plus yj b vector plus zj c vector dot with n vector is equal to 2 pi by lambda 2 pi by lambda xj a vector dot n vector, it is xj a vector dot n vector plus yj b vector dot n vector plus zj c vector dot n vector. A dot n vector is equal to 2 pi by lambda xj a dot n as h lambda plus yj b dot n as k lambda plus zj c dot n l lambda. When expanding it, we have lambda lambda cancel out, 2 pi as common, h xj plus k yj plus l zj. The phase difference is evaluated. Therefore, f HKL is equal to summation over f of j e to the power I. In place of phi j, we substitute its value as 2 pi hxj plus kyj plus l zj. If all the atoms are similar in a cell, then the atomic scattering factor is same for all. So f of j will be same for all the atoms. Instead of f of j, we can simply write f. Therefore, f of skl is equal to small f, atomic scattering factor, into that given term. That given term is nothing but zeta, geometrical scattering factor. Therefore, zeta is equal to f skl divided by atomic scattering factor f. We derive that expression for geometrical structure factor. Geometrical structure factor is equal to f skl divided by f. That will be the derivation. Now, by using that geometrical structure factor, we can analyze what be the structure of given crystals. The significance of geometrical structure factor. The physical significance of geometrical structure factor zeta is that there is no intensity and reflection n allowed by the space lattice corresponds to 0 value of zeta. By using that, the missing reflection helps us to determine the structure of lattice of the crystal, and that geometrical structure factor is not real, that is an imaginary term. Therefore, the intensity of radiation, is proportional to the square of its amplitude, Therefore, I, intensity of radiation, square of its amplitude, magnitude of f square, that is equal to f and the conjugate of f, where f star is the complex conjugate of f. Hence, the intensity I, look that expression, e to the power something, e to the power I theta, that is cos theta plus I sin theta. So, the intensity is equal to summation over f of j cos 2 pi h x j plus k y j plus L Z j its square plus again I sin theta and its magnitude as summation over j f of j sin 2 pi h x j plus k y j plus L Z j. By using the concept of geometrical structure factor, we can analyze the structure of that of lattice and again the intensity of that given radiation. Next, by taking the examples and the geometrical structure factor, we conclude what be the shape of the structure. For simple cubic crystal, there is only one atom per that of unit cell that present at origin. Therefore, its coordinate as xj, yj and zj are 0, and f of skl putting all these terms are 0, it will be equal to f, that is equal to f. Hence we conclude that all the lines predicted by Bragg's law will occur provided atomic scattering factor F is sufficiently large to makes the peaks of intensity visible. As f scale is equal to atomic scattering factor, we can easily visible that intensity. Next, for BCC crystal, there are two identical atoms per unit cell. One is contributed by the corner atoms of the cell and other are the center of the cell. For that reason, one is at center, so the coordinate xj, yj and zj is equal to 0. That for corner atom. And xj, yj plus zj is equal to half. That is the atom for body centered. For atoms at body centered. Hence, f of HKL magnitude is equal to f summation over j e to the power I 2 pi h xj plus k yj plus L zj. First, taking xj, yj, zj as 0, then half. First putting 0, e to the power 0, it will be 1. So f as 1 plus, next putting half, 2 into half cancel out. So we have e to the power pi I h plus k plus L. Now we have to choose SKL. For S plus K plus L, if odd, that is for F, S, K, L magnitude for e to the power pi I h plus k plus L. If h plus k plus l is odd, then e to the power that quantity will be -1. And if h plus k plus l is equal to even integer, then e to the power pi I h plus k plus l is equal to 0. For odd it will be -1, for even it will be 0. Therefore, f h k l magnitude is equal to so f 1 minus 1 that is equal to 0 for odd integer, and f h k l is equal to f 1 plus 1, which one is equal to 2f, that is for even integer. Therefore, we have two sets. From this we conclude that first order reflection for body centered cubic crystal structure does not take place from the planes like 1 0 0, 3 0 0, 1 1 1, 2 2 1. 1 0 0 the sum will be 1, 3 0 0 sum 3, 1 1 1, 1 plus 1 plus 1 3, 2 plus 2 plus 1 that is 5, all are odd. For that of odd, f scale will be 0. Therefore, it does not take place for these given planes. Next, for even it will be appeared etc., but will occur from the planes like 2 0 0, 1 1 0, 2 2 2 etc. 2 1 plus 1 2, 2 plus 2 plus 2 6, all are even. For even it will be exist, it will occur from the planes like these three. For these planes it does not exist, for that planes it exists. That we conclude from that of particular mathematical expression. Next, for face centered cubic crystal structure, the basis for the face centered cubic crystal structure has 4 identical atoms for unit cell, 1 contributed by the corner atoms and the 3 contributed by the face centered atoms. Therefore, the coordinates of these atoms, the coordinates of these 4 atoms are, one is at center, so it has 0 0 0, and another 3 are the face centered. For face centered you have 0 half half, 2 half 1 0, it is organized as half 0 half, and half half, 0. Now we use all these coordinates in that of amplitude term. Thus the diffraction amplitude f h k l is equal to f. First we put HKL as 0 0 1, then HKL as 0 half half, like this. So it will be 4 terms. First putting 0, e to the power I pi I, in that of expression we put first for HKL as 0, then 0 half half, like this. We have 4 terms. Each terms are written as f. Putting 0 we have 1, next putting 0 half half, now e to the power pi I h plus k, next putting half 0 half, e to the power pi I k plus l plus e to the power pi I l plus h. Now for even and odd combinations, for all even or odd indices, f s k l is equal to f 1 plus 1 plus 1 plus 1, that is equal to 4f, and the intensity which is proportional to square of amplitude 4f square, that is equal to 16f square. For all even or odd indices we have that scenario. If one of the indices odd and other two are even, if one of the indices, let us say h is equal to odd and other two are even, then the terms are e to the power pi I h plus k is equal to -1, e to the power pi I l plus h is equal to -1, and e to the power pi I k plus l is equal to -1. Then we say f of h k l is equal to f 1 minus 1 minus 1 plus 1, and finally it has 0. For even or odd we have something, and if one is odd and another two are even, one of the indices odd and another two are even, then it has 0. So an important point we write here, since it will be 0, so intensity will be 0, intensity is 0, amplitude 0 means intensity 0. Hence in an FCC structure, no reflection takes place. For which the integers are partly even and partly odd, partly even and partly odd. No intensity, intensity will be 0, but reflection present for either even or odd. Therefore, with the help of this video lecture, we understand the concept of geometrical structure factor, and mathematically we show it, derived that expression of geometrical structure factor, physical significance of geometrical structure factor, and by using geometrical structure factor we know for simple cubic crystal, for body centered cubic crystal, and for face centered cubic crystal. So, with this useful and informative notes, let me wind up this session. Thank you.